thank you all for coming. Today I'd like to talk about RubyMotion, but maybe in a little bit of a different way than what you've seen in the past. So hopefully all of you have at least heard of RubyMotion. If not, don't worry, I'll mention it. But instead of talking about just how to use it or what it is, I'd like to take a bit of a deep dive today. OK, so first off, I'd like to start with a brief introduction about me. As I said, my name is Joshua Ballanco. I am currently chief scientist at Burnside Digital, and I live and work from my home in Ankara, Turkey. Now, that's usually the only introduction I give. But I actually have a little bit of history with Boston and Ruby. So I thought that for today, and today only, a slightly longer introduction was warranted. So before I was in my current situation, my name is Joshua Ballanco. I worked for Patch and lived in New York City. If we go a little bit further back, my name is Joshua Ballanco. I worked for Apple and lived in Cupertino. And if we go a little bit further back than that, my name is Joshua Ballanco. I went to graduate school at University of Miami, lived in Miami. Before that, my name is Joshua Ballanco. You killed my father. Prepare to die. Sorry, I was getting a little punchy when I was putting these together. OK, now why am I giving you that extended introduction? Well, I think it helps to sort of frame my approach to RubyMotion and to give you a little bit of my history as to how I got to RubyMotion. So when I was in graduate school, I did work in bioinformatics. And in the field of bioinformatics, most researchers use this package called BioPerl, which, as the name suggests, is based on Perl. Well, I took a look at some of the code and kind of looked at the libraries, and I was like, you know what? I'd much rather be using Ruby. Actually, to be perfectly honest, I knew I wanted to use anything but Perl, so I evaluated both Python and Ruby. And in one of the rare cases where I actually picked the wrong thing, it turns out that I went with Ruby while most of the rest of the scientific community went with Python. Yeah, such is life. Anyway, fast forward a couple of years, and I moved to New York, and I actually got a job at the Apple Store, Fifth Avenue. I was working the night shift. Now, you might imagine that there's not a lot to do in an Apple Store at 2 a.m. on a Saturday, and there isn't really. But I was surrounded by all these computers. I was using Ruby in my research at the time. This was a part-time job while I was still in graduate school. And I had just recently heard about this framework called Rails. So I figured, ooh, this is kind of interesting. Why don't I build a couple of Rails apps for use at the store? So I did that. And I think they're even still using one of them today. But what I did is eventually I kind of got tired of selling computers and decided I wanted to build them instead. So I showed my Rails applications to a guy I had a contact with at the server group in Cupertino. And I got an interview for a position in Cupertino. And during the interview, I made this offhand comment. Towards the end, I said, yeah, you know, I've been doing a lot of work with Ruby recently, and it strikes me that the Objective-C object model and the Ruby object model, they're not that different. Wouldn't it be kind of interesting if you could implement Ruby on top of Objective-C? And he said, you need to talk to this guy named Laurent Sansonetti. For those of you who don't know, Laurent Sansonetti is the author of MacRuby, and at the time was also working for Apple. So I got to Cupertino. I immediately emailed Laurent. And that started a multi-year collaboration on MacRuby. And then eventually, I left Apple. And eventually, Laurent left Apple as well. When I left Apple, though, I came back to New York. And I gave a presentation to one of the New York Ruby meetups on MacRuby. And a short while after that, I got an email from this guy who said he was the organizer of the Boston RB meetup. He said, would you like to hop a train to Boston and give a talk? I said, would I? I love the train. And as it so happens, I love Boston too. And that led to this first talk that I gave, and apparently it was well enough received that they asked me back for a second one a couple of months later. And the reason I bring this up is because both times when I came to Boston RB and talked about MacRuby, I was asked the same question. And it was a question that Laurent and I had gotten used to being asked over and over and over again. And that is, when can I use MacRuby to build iPhone apps? And both times I had to be very coy about it because I knew what was going on. But I couldn't say anything until RubyMotion was actually publicly released. So I mention all of this because I would actually like to think of this talk today as the third part in my trilogy of Boston MacRuby RubyMotion talks, the return of the RubyMotion. OK. So with that out of the way, what is RubyMotion? So if you haven't figured it out by now, RubyMotion allows you to use Ruby to build apps for iOS and more recently also for OS X. These are native apps. So this is not a translation layer. It's not a simulation. It's not some sort of layering on layering on layering. When you compile these apps, they are compiled native apps. And so this allows you to directly interact with Objective-C classes, with Objective-C libraries. There's the CocoaPods tool that you can use, like Ruby Gems, to pull in open source Objective-C libraries. You can use Ruby Gems as well. And all of this is done with a command line driven build system, which is really nice. I've had people tell me that they use RubyMotion simply so that they don't have to deal with Xcode, which, having worked at Apple, I can sympathize. Now, there are lots of great resources if you would like to know more about RubyMotion. The RubyMotion site itself actually has a decent number of documentation and community resources that you can look up. There's a couple of other resources. Motioncasts is this really neat series of screencasts. And there's a website, RubyMotion Wrappers, that actually is collecting a list of all the various libraries that people have built to take Objective-C, either built-in classes from the Objective-C APIs, or even third-party open source libraries, and wrap them up in a slightly nicer Ruby interface. And the community is really great. We had our first conference earlier this year. The mailing list is very active. The IRC channel usually has some activity going on. There's been a series of online meetups that we've had. So there's really a lot of great resources out there if you'd like to learn how to build iOS apps with RubyMotion. I mention this because I'm not actually going to tell you how to build iOS apps with RubyMotion today. I think there are lots of people who have done many presentations that are way better than any that I could give. So I figured instead I would focus on sort of where my expertise lies. And that is with what goes on under the covers. OK, so to understand what's going on underneath all of this, we have to rewind a little bit and talk about what is MacRuby. So as I mentioned, when I moved to Cupertino and started working for the Apple OS X server engineering group, originally, MacRuby was intended to be the Ruby 2.0 implementation for OS X. That was the plan. Never happened. But as such, we were targeting the Ruby spec. We were using Ruby spec as a benchmark of how compliant we were, the goal being eventually 100% compliance. And at the same time, though, we were building MacRuby because we had been using RubyCocoa as a bridging layer between Objective-C and Ruby. And it's not really a great bridging layer. I mean, it did the job at the time. But we wanted to be able to build both Ruby scripts and run Rails and do all the stuff that you expect Ruby to do, but also be able to build native applications. So we gave it a just-in-time compiler, but we also gave it a mode where you could compile things ahead of time. And at the same time that we were building MacRuby, Objective-C also had just recently gotten a garbage collector called libauto. And we said, hey, this is great. I mean, Ruby needs a garbage collector, and the one in MRI is not so great. So why don't we make use of libauto? And that's exactly what we did. So this was kind of the lay of the land for a couple of years when we were building out MacRuby. Now, just to dive a little bit deeper into how MacRuby actually works. This is actually a slide I showed, I think, the first time I came here to talk about MacRuby. I just wanted to revisit it because, as you'll see in a second, it can help you understand sort of why MacRuby is the predecessor of RubyMotion, but also a little bit different than RubyMotion. So with MacRuby, you start off with a Ruby file, obviously. And we take that Ruby file and we parse it. And then from the parsed output, we hand that off to the compiler. And the compiler then interfaces with both the virtual machine, which contains all of the global state and coordinates all of the object creation and method definition. And then we also use LLVM to turn Ruby code into bit code, which then eventually gets turned into native code. The whole time, the code that's getting compiled with LLVM and the virtual machine itself are interfacing with the Objective-C runtime to coordinate, again, object creation, method definition. And this is what allows us to actually seamlessly interact with Objective-C libraries. OK, so what does this look like in practice? Well, if you're going to run a file, if you just have a Ruby file, some RB file, and you want to run it with MacRuby, how does that work? So we start off, as I said, we go through the syntax, we parse it, we compile it. Then the virtual machine and the bit code compiled code from LLVM will talk to each other. They'll call into each other. Method definition will call into the VM. The VM will have callbacks into the code. And the whole while, they're both talking to Objective-C. But we can also do ahead-of-time compiling. Right? So you can just say MacRuby somefile.rb and it runs the file. Or you can say MacRuby C. Right? MacRuby C is the executable that actually compiles these files. Right? And if you do MacRuby C, we actually ahead-of-time compile. That takes us through the parser, the compiler, does bitcode compilation with LLVM, and spits out an object file. OK, so if you've ever done work with C or C++, this should be a fairly familiar workflow. Right? You have your source code, you turn it into an object file. Now, with C and C++, eventually you link the object file. And actually, believe it or not, you can link these object files the same way. Right? But however you do it, eventually what ends up happening is that you put that something.o file in place of the bitcode compiled file. You're still talking to the virtual machine. Right? There are still calls back into the virtual machine to manage object creation and whatnot. And they're still both talking to the Objective-C runtime. But we can cut out a lot of the hard work of actually parsing and compiling. So ahead-of-time compiled code with MacRuby runs faster. And also because it's compiled to an object file, it's more portable. Ruby, however, is an interesting language. It allows you to do a lot of kind of crazy things, like at runtime, reevaluate code. And what that means is that we can't actually get rid of the LLVM part. We have to allow for the possibility that during execution, there will be some string that is Ruby code that we then need to go back up to the parser and ask the parser to parse, the compiler to compile, and generate new bit code. Right? So this is all possible with MacRuby. This is how MacRuby works. This is how we are able to compile code, but at the same time maintain 100% compatibility with Ruby. So that brings us to RubyMotion. Okay, so we worked on MacRuby for a number of years, as I said, and we had high hopes for it, but the lay of the land changed. This thing called the iPhone came out, and then later on this thing called the iPad came out. All of a sudden, Apple wasn't so interested in servers and stuff like this. But we knew that there was still a future for MacRuby, and specifically in the context of iOS. And so that's where RubyMotion comes in. It's a descendant of MacRuby. It's not a fork per se, but sort of a natural progression. Unlike MacRuby, though, RubyMotion does not aim for 100% compliance. There's a good reason for that. I'll show you in a second. It's more like Ruby the good parts. So most people using RubyMotion will probably never realize that there are certain things that you can do in Ruby that you can't do in RubyMotion. Most of these are sort of obscure metaprogramming or various corner cases of the Ruby runtime that you could probably live without. Also, instead of being able to run these things dynamically, now your files are all completely statically compiled down to a single executable. And instead of a garbage collector, we now have reference counting. OK, so going back to this diagram I had before of how this whole system works, what does it look like when we statically compile with RubyMotion your something.rb file? Well, again, we're going to parse the syntax. We're going to go to the compiler, and the compiler is going to emit LLVM bitcode. And the LLVM bitcode is going to be compiled into an object file. If you have RubyMotion and you are compiling a project, you'll notice that as part of that process, it creates a build folder. And if you dig inside of the build folder, you will find .o files. Where things get really different, though, is when you actually go to run it. So when we actually link everything together and create that single static binary, what happens now is, again, that object file is going to interface with the RubyMotion runtime. Got to make sure I don't mix up MacRuby and RubyMotion. And they're both still built on top of the Objective-C runtime. But you notice what's missing, there's no more parser, there's no more compiler. So runtime evaluation of Ruby source is not possible. Now, there's a good reason for that, right? Because on OS X, when we compile, if we runtime compile code, what we're doing is we're actually taking some piece of memory and we're writing bits into that memory, right? So we're writing to the memory. And then we're immediately turning around and taking that memory page and handing it off to the processor and saying, here's some code, go run it. Now, if you've done any iOS development, any development for the iPhone or the iPad, you'll know you're not allowed to do that. And there's actually a good reason for this, right? This is a security concern. This is one of the main ways that most viruses work, right? Most exploits take advantage of the fact that you can write to a memory page and then turn around and convince the processor to run it. On iOS, this isn't possible. On iOS, memory can be writable or executable, but not both. So after you've set a program off running, you have to say, this is all the code that I'm going to run, and this is all the memory that I'm going to write to and read from. But never the twain shall mix. So the OS actually prohibits us from doing runtime compilation. You can't eval by writing code into memory. Now, if you're astute, you might say, well, Josh, but that doesn't matter. We don't need to actually write the code into memory, right? We could just, as the file is being parsed, fire off function calls using an interpreter. You could, but Apple won't let you. Right? This is that famous restriction on running code that was, well, JavaScript gets a pass, but whatever, JavaScript's JavaScript. As it turns out, you wouldn't actually want an interpreter anyway. Interpreters are slow. And there's a reason that even back in the days of working on MacRuby, we preferred to do the ahead-of-time compilation. Because doing interpretation at runtime it sucks. OK, so moving on and talking about the garbage collector. What happened to it? Right? I mentioned that RubyMotion uses reference counting instead of garbage collection. Why is that? Well, it turns out libauto, the way that it works, actually the way that any garbage collector works, is you really have only two options. You can stop everything to collect the garbage, or you can let the program continue to run and collect the garbage on another thread. Now, on a big, beefy processor with multiple cores, it's not such a problem. But on a device like the iPhone, especially the early iPhone, this just wasn't an option. So Apple ditched the garbage collector. There are other language runtimes that you can use on iOS that have garbage collectors. JavaScript, Lua. But they pay a penalty. And with RubyMotion, we really didn't want there to be any penalty. We wanted to be able to create native apps, just like as if you were running Objective-C code. So RubyMotion uses ARC, right? Yeah, well, not really. Kind of. There's been a bit of confusion about this point, and it's completely understandable. So around the time that, or shortly after, I guess, iOS came out, right? I mean, originally, when you were programming in Objective-C, you had to throw these retain, release, auto-release bits all over your code. And, I mean, that's been the way it's been for ages, right? People just kind of got used to that. But it's really a burden to have to do that. Garbage collectors prevent you from having to manage memory on your own. But Apple figured out there's another way. We can actually just analyze your code, figure out where those retain and release statements should be, and put them in for you. And they called this technology ARC, for automatic reference counting. When figuring out how to replace the garbage collector from MacRuby while creating RubyMotion, Laurent came up with a similar but different idea. So when Objective-C does automatic reference counting, what's happening is that the compiler, as I said, it's actually analyzing your code, figuring out where to put in the retains and releases, and modifying the code to add those retain and release statements, and then compiling it and generating your object file, et cetera. In RubyMotion, we're not actually modifying the code. Instead, the VM, the virtual machine, knows where all those retains and releases should be, right? So, I mean, retains and releases, if you're not familiar, it's usually around assignments, right? When you assign a value to a variable or reference something or a value goes away. All of those processes that happen that would require reference counting to happen necessarily involve interaction with the virtual machine. So in RubyMotion, what we can do is we can have the virtual machine add the retain and release without modifying the code. It's kind of an academic distinction, isn't it? Does this really matter? Yeah, I mean, it doesn't really matter, right? For all intents and purposes, RubyMotion handles your references for you so that you don't need to worry about managing memory. And it does it without a garbage collector. There are some caveats. So unlike garbage collection, which can happen at pretty much any time, or usually happens during object allocation when we don't have enough memory to create a new object, with ARC, collection only happens at the end of a auto-release pool drain. There is a top-level auto-release pool in the run loop. So every time you run through a run loop cycle, you drain a pool. So usually you don't have to worry about that. But if your code has a tight loop in it somewhere, and you're doing a lot of object creation, you could potentially exhaust memory without ever getting a chance to tick over to the next auto-release pool drain. And so there's actually a convenience in RubyMotion, this auto-release and then a block, do, end, or in brackets, that will actually wrap up that piece of code in its own auto-release pool. So if you have a tight loop where you're doing a lot of object allocation, just make sure that you wrap it up with this auto-release, do, end, and you should be fine. The reference count could potentially run into problems with retain cycles, where A references B and B references A, and then how do you ever get the two to go away? Because they both always have at least one reference to each other. And early on in RubyMotion, this was a known problem. There were some suggested ways to work around it, but it kind of sucks. So more recently, the guys at HipByte have actually managed to get the automatic reference counting in RubyMotion to break those cycles. Now, if you are a student of computer science, you will probably recognize that automatically detecting all possible retain cycles is equivalent to solving the halting problem. So it can't find absolutely all cycles, but it will find almost all the cycles that will ever occur in normal code. That said, there is also this new weak ref class, so that if you know there is the potential for a retain cycle, use a weak ref to reference the other object, and that way you can be sure that the cycle will be broken. OK, it's all a bit academic. We're getting a little short on time here, so let's get to the meat and potatoes. So what about when you want to debug RubyMotion? Well, remember, RubyMotion is built on top of the Objective-C runtime. RubyMotion objects are Objective-C objects. So all the tricks that you can use with Objective-C, you can also use with RubyMotion. But it's even better than that, because you have RubyMotion, right? The guys building Objective-C code, they don't have RubyMotion to play around with, so let's play. OK, so here's what I did. I created a simple little project, called it Playtime. And this is what the victim file looks like. It doesn't do anything. It's a blank screen if you actually run it in the simulator. I just wanted to play around with Ruby objects and the debugger. So I just created this object. Now this top thing here, this is kind of fun. The Grand Central Dispatch Library has this notion of dispatch once that basically ensures that any code inside of there will only ever run once on any thread. So if you want to create a singleton, this is how you do it, right? That instantiation code will only ever run once, even if you run this across multiple threads. OK, so we've got a basic singleton that we're going to deal with. Initializing it is going to create an array for this instance variable called refs. And then we just have two methods to assign an object into that array or to clear out the array. OK, and just for completion's sake, the rest of that file just looks like this. This is the boilerplate that gets generated whenever you generate a RubyMotion project. And I just went ahead and created a first instance so that we have it to play with. OK, so from the command line, because remember, RubyMotion is all command line driven. From the command line, if you go ahead and type in rake, it's going to build your app. It's going to start up the simulator. Like I said, it's just a blank page because we haven't actually built anything. But it also pops up a REPL. Tell that to your Objective-C programming friends. I get a REPL when I run my program. That means you can do fun stuff like this, right? Let's make sure that this is actually a singleton. So if I call instance on the foo class twice, you'll notice both times it's the same object ID, right? That's a singleton. Cool. All right? So first time, second time, same object. OK, in the REPL, let's create a string. OK, simple hello. And let's go ahead and use that method that we had there to assign it into that array that we have. Let's do it again. Now we've got that one string object inside of that array twice. That array has two objects, right? This is basic Ruby stuff, right? What's the retain count on string? Well, we can ask it. How many of you remember the retain count method from Ruby? It's not there. So this is kind of the first really magical thing about the RubyMotion REPL is that because RubyMotion objects are Objective-C objects, you can call Objective-C methods on them. Retain count is an Objective-C method, and it tells you how many references there are to that object. All right, and now if we call that clear method that we had that empties out the array, and we ask for the retain count again, we see that it's been decremented by exactly 2, exactly the number of references that we had to it in the array. So before you go jumping to the debugger, you might not even need the debugger. You might be able to debug your code just simply using the REPL. And keeping in mind that all of these RubyMotion objects that you're creating, you can call Objective-C methods on them. Same as you do when you're writing your RubyMotion code, you can do that in the REPL as well. OK, that's kind of cool. But can you do it in a debugger? So if instead of running rake to do the default build and simulate, if you pass in this argument or set the environment variable debug to 1, then rake will, instead of popping up a REPL, it will pop up an interface to LLDB. It's recent that we've switched from GCD to LLDB. GDB to LLDB. So LLDB is a low-level debugger. It's part of the LLVM project. And it lets you do fun debugging things. Now, if you've done any debugging in C land, things are a little different, right? So RubyMotion, being Ruby, is dynamic. You don't need to specify types. But LLDB, living in C land, is statically typed and does need to know about types. So instead of being able to just simply call foo instance, right, if I do attempt to call foo instance, and by the way, I highly recommend you play around and break things. And this is usually the only way that I learn, is I pop up the debugger and I type codes until it crashes, and then I start it again and I type some more. Right? And it gives you hints, right? So if you try and call just foo instance in brackets without giving it a type for the return value, it'll say, that's really great that you want to call the instance method, but I don't know what it returns. If you tell me, I'll run it for you, though. And so that's what we do. We tell it with the typecast that this is going to return an object reference, right? In Objective-C land, that's type ID. But you see, we're doing the same thing that we did in the Ruby REPL, right? We're calling foo instance twice. Oh, and by the way, did you notice that we're using the Objective-C syntax to call a Ruby method? That's kind of cool, right? Yeah, so if we call instance twice, we're getting back the same object both times. It's still a singleton. OK, it gets a little bit crazier here. Because we're doing the same thing again, but we need to do all of these typecasts, right? So we can't just assign a variable. We have to tell it what kind of variable it is that we're assigning, and then we can assign a variable. So we're saying, OK, we're going to create an NS string. Got it? Good with that? OK. And we're doing this by calling NSString alloc init with CString, passing in the hello CString. And by the way, that method returns an NSString pointer. Right? This is all the sort of hand-holding that you have to do for LLDB to make it work. But then we've got the string. Right? So if we inspect it with expression, it tells us, the object ID, and it says, hello. OK. And then we can go ahead and we can do the same thing. Right? But again, when we call foo instance, we have to tell it, foo instance will return a foo pointer. OK. And then we get to call assign. Right? If you don't include that foo pointer, it'll say, it's nice that you want to call assign, but I don't know what assign return. OK, fine. Right? So, or even foo instance. Right? So foo instance returns a foo pointer. Assign is going to return an NS array pointer. Right? This is Ruby's convention of returning the last thing in the method. But if you do that, you see that we get the same array back twice, which is this instance variable. And if we inspected it, we'd see that the first time it has one instance of the string in there, and the second time it has 2. So now we can go back and we can ask the string for its retain count. Right? Same thing. Except we have to tell it that it's an NS string, and we have to tell it that retain count returns an integer. OK. More hand-holding. But if we then go ahead and call clear on the instance, right? So again, foo instance returns a foo pointer. Clear doesn't return anything. Actually, I could have told it returns anything, but it believes me. And then we ask for the retain count again. You see, again, it's decremented by exactly 2. The exact same thing happens, right? So here we have the RubyMotion REPL on one hand, LLDB on the other hand. You can do the same thing in both. Now, you might say, why would I ever want to use LLDB, right? This is crazy. Yeah, I know, but it's fun, right? No, there is actually a good reason, because what you can't do in the RubyMotion REPL is do some of the crazy Objective-C type things that you might need to do when you're debugging Objective-C code, right? So if you're only ever working with RubyMotion, chances are you'll never actually need to go to LLDB. Chances are the REPL will do everything that you need to for it, assuming that the runtime works and that there's no bugs in RubyMotion, which, I mean, there's not a software product in the world that's bug-free. But chances are that if working in the RubyMotion REPL isn't doing it for you, instead of running off and wasting a day in LLDB, you should probably just file a support ticket instead and say, I really tried, but something's just not working. If, however, you happen to be working with both RubyMotion code and Objective-C code, right? So you've got a CocoaPods library, or you're doing something with some Objective-C library somewhere, then it's conceivable that you might need to be working in LLDB instead, because LLDB does have access to the things that you need to debug Objective-C that you don't have access to in the RubyMotion REPL. But keep in mind that you can still do all of the same things that you can do in the RubyMotion REPL inside of LLDB. There's a little bit of translation and a bunch of extra typecasts that you have to add in, but it still works. There's also a couple of conveniences. So there's this PRO, which is print Ruby object, and PRI, which is print Ruby instance variable. These are helper methods that exist in LLDB, so that when you run it in debug =1 mode, you can use these to simplify, so you don't have to do quite as many typecasts. There's actually an entire page on the RubyMotion website that describes how to do some of the debugging. And we definitely, I think there's definitely a recognition that debugging could be better. Debugging is hard, and so it's probably not a surprise that building good tools for it is doubly hard. But definitely keep an eye out, and you might find something coming down the pipe. So with that, thank you for your attention, and if you have any questions, I'd be happy to take them.